Alright, let's make the list of possible rational zeros here. We start with the factors of 10, and you just list them out. 1, 1, 2, 5, 10. Then you have 1/3, 2/3, 5/3, and 10/3. The other factor of 3. Here we're going to create our possible zeros, and since we only have 1 and 1, so we can only have plus or minus 1. So I'm going to start with 1, and I'm going to list out our coefficients of the function. 1, 2, -2, -1. Oh, but we forgot our 0 because we don't have any x squareds. Please don't forget that. So I have to put a 0 as a placeholder for the x squareds. -2, -1. 1, bringing down, 1 times 1 is 1. 2 and 1 makes 3. 1 times 3 is 3. 0 plus 3 is 3. 1 times 3 is 3. 3 plus -2 makes 1. 1 times 1 is 1. So 0. So we know that this is an x cubed function. If you were to read it aloud, you'd say x cubed plus 3x squared plus 3x plus 1. Okay? But I don't know that I can necessarily factor that, and actually the safest way in this sense to save room and whatnot is to continue with our synthetic division. So I'm going to try our -1. So I'm going to put our hockey stick down, and I'm going to try -1. Bring down the 1. 1 times -1 is -1. 3 minus 1 makes 2, or 3 plus a -1. 2 times -1 makes -2. 3 and -2 makes 1. 1 times -1 is -1. And we end up with our 0. Beautiful. Now we can rewrite this as our x squared plus 2x plus 1. That is perfect because that will factor to x plus 1 and x plus 1. When we set that equal to 0, we get x equals -1, and that's going to repeat, it looks like 3 times. Okay, we already have it here, and then we have it here and here. So repeated 3 times. And then your other 0 is 1. So that is all the zeros of your function. Okay? So that's A. For B, same thing, except we're going to start with the factors of 4 all over 1. Then the other factor of 2, because it would have been 4 and 2, the other factors of 2, we have to do the exact same thing. So we start with 1 over 2, then 2 over 2, then 4 over 2. But the cool thing is that these cancel, because 2 over 2 is 1, and 4 over 2 is 2. So our only list is right here of possible zeros. So then I start with 1 again, and I go 2, -1, 8, -4. So I go 2, 2, 1. 1 times 1 is 1. 8 and 1 makes 9. 9 times 1 is 9. And 9 and that makes -5. So 1 is not a 0. So I need to erase that. I don't have a lot of room here, so I'm going to re-erase this and start over. But I expect you guys to just continue on. Try another one. Show me your attempts. Make sure you show me. I need to see all of them. Okay, so we're going to start with -1. 2, -2, -3, 3, 11, -11, that makes -15. Alright, so that's not going to work either. So again, we need to try a different one. Alright, so let's try 2. Again, this is 8 and -4 down here and -1. Okay, cool. So I bring down the 2. 2 times 2 is 4. -1 and 4 is 3. That makes 6. 14. 28. Whew. Negative 2 doesn't work. Alrighty, let's try another one. So we'll try negative 2. Hopefully we don't have to go through the entire list. Bring down the 2. 2 times negative 2 makes negative 4. That makes negative 5. That makes positive 10. That makes 18. That makes negative 36. Oh my goodness. Alright. Well, I'm going to just continue on here. Let's see. Why don't we try 1/2? See how that goes. Bring down the 2. This makes a 1. That makes 0. 1/2 times 0 is 0. 8 plus 0 is 8. 1/2 times 8 makes 4. And negative 4, 0. Alright, cool. That's awesome. That right there tells me that I've found a 0. 1/2 is my first 0. Now I should have at least 3 other zeros. So right now I know that this is in quadratic form. This is 2x squared plus 8 equals 0. So what I need to do now is solve this. So if I subtract 8 from both sides, 2x squared equals negative 8, then x squared equals negative 4 because we divided both sides by 2. Okay? When you take the square root, you get x equals plus or minus 2i. Wow, so we have 2 imaginary zeros here, and we also have x equals 1/2 from our synthetic division. All right, now I just happened to pick 1/2. You may have, had to try 4 and negative 2 and then get your way to 1/2, or you could consider putting all the zeros in order from least to greatest and going that way. I don't know, but that's how you find all the polynomials, okay? Or all the zeros of a polynomial. All right.